All right, so we're going to talk more about trends today. We already know two trends. We know one for atomic radii and one for ionic radii. And today we're going to learn about two words that you probably have never heard of before, and that is electronegativity and ionization energy. So let's first talk about electronegativity. Electronegativity is the ability of an atom to attract electrons when already in a compound. So this when already in a compound part actually makes it to where it's going to eliminate some of the elements from having electronegativities. So electronegativities are only for elements that bond with each other. So that's going to leave out a particular column on the periodic table. Which column on the periodic table does not generally create compounds? And if you knew that was the noble gas column, you're correct. All right, so let's talk about which elements have higher and which elements have lower electronegativities. So metals have low values for their electronegativity. And once again, we're going to talk about that element francium. So remember, francium was the element we used for our largest size, but it has the lowest electronegativity. So the closer you are to the element francium on the periodic table, so here's the general outline of the periodic table, and here's Mr. Francium down here in this bottom corner. He has the lowest electronegativity. So metals have low values. Electronegativity values are listed on the back of your periodic table. So if you flip over your periodic table, you'll see francium's electronegativity value is 0.7. Okay, so that is its electronegativity value, and it's in Paulings. Okay, nonmetals have larger electronegativity values, and fluorine is the highest of the electronegative elements. Now remember, the noble gas column is completely X'd out. So if you have the noble gas column X'd out, you'll see that fluorine, here's fluorine, and here's francium. So francium has the lowest value, and fluorine has the highest value. And fluorine's value is 3.98. Okay, so francium's is 0.7 and fluorine's is 3.98. And the noble gas columns don't have any. So there's these two F elements on the periodic table. And if you know the electronegativity for francium and fluorine, then you could figure out the electronegativity trend for any other element. So the closer you are to francium, the lower your electronegativity is. And the closer you are to fluorine, the higher your electronegativity is. So fluorine is the element that is most likely to attract electrons. The reason being is because she's got the most protons of anybody in her row. And francium has the lowest number of protons in anybody that's in the same period. Okay, so it increases as it goes across the period, because remember, fluorine is the highest, and it decreases as it goes down. So the reason it increases, as I said a moment ago, is that as you go across the periodic table, you keep getting more and more protons as you go across. That means your nucleus keeps getting stronger and stronger. And the stronger your nucleus is, the more likely it is that you can grab in an electron that's whizzing by. All right, so the increase in the number of protons means you have a higher effective nuclear charge. So it is going to increase the nuclear attraction for an electron as you go across. All right, remember, this is the same reason that my molecule that my element, my atom, was getting smaller as I went to the right. So my reasons are the same as they were the day before yesterday, and they are going to be the same for why we get decreasing as we go down as well. So it's going to decrease as we go down a group. What were the reasons that we got larger as we went down a group for size? The two reasons were we kept on getting new energy levels and we kept getting shielding electrons. Okay, that's the same reason we're going to decrease now in our electronegativity. Every time we get a new energy level, the electrons get further and further away from your positive nucleus. So I've got a nucleus here in the center that's positive. And every time I add a new energy level, the electrons are then further and further away, and their ability to be pulled in keep getting less and less. So as I go down a as I go down a group on the periodic table, I'm going to decrease because I keep getting more energy levels and I keep getting more shielding electrons, which block the ability from my nucleus from pulling in this outermost electron. So in an illustration, it decreases as you go down, it increases as you go across. Francium is your lowest with an electronegativity value of 0.7, and fluorine is your highest with an electronegativity value of 3.98. So remember, the noble gases don't have electronegativities because they don't participate in bonding. So increases makes this one the furthest one over to the right. And so the closer you are to fluorine, the higher your electronegativity value is. So knowing that, let's think about the periodic table when we answer the following questions. Which has a higher electronegativity, lithium or carbon? Find lithium and carbon on the periodic table and see where they are relative to fluorine. Whichever one is closer to fluorine will answer which is the higher. Okay, if the question was asking which was the lower, it would be whoever was closer to francium. But this question says which is the higher electronegativity. So who's closer to fluorine, lithium or carbon? And the answer, of course, is carbon. So carbon has the higher electronegativity. Who's closer to fluorine, sodium or potassium? So sodium is here, potassium is here. Who's closer? Sodium. Boron or beryllium? Beryllium's here, boron's here. Who's closer? Boron. So just a matter of knowing which element has the highest electronegativity value, and you could answer any of these questions with ease. Bromine or fluorine? This one's super easy because fluorine does have the highest value. So of course it's going to be higher than everybody else on the periodic table. But if you look at the trend, higher up is higher electronegativity. Nitrogen or phosphorus? So nitrogen is here, phosphorus is here. Closer is going to be nitrogen because it's in the same period as fluorine is. So nitrogen has the higher. Boron or nitrogen? Boron or nitrogen? Who's closer to fluorine? Nitrogen is. Okay, so that's electronegativity. Electronegativity is based on the proximity on the periodic table to fluorine is going to have the highest, closer to francium is going to have the lowest. And electronegativity is the ability to attract someone else's electron while in a compound. And fluorine is the most attractive element on the periodic table. Her protons only have 2 energy levels worth of electrons to shield. from it being able to pull in an electron, and she's got a full contentment of 9 protons in her nucleus, so she's able to bring in other people's electrons easily. Ionization energy is the other word that we're going to talk about today, and it's kind of similar to electronegativity, except it's not. It's not the same, but it's a little bit the same. So let's talk about what it is. So ionization energy is the amount of energy needed to remove an electron from the gaseous state. Now remember, electronegativity was the ability to attract someone's electron to you. So this is how easy it is to take an electron away from you. Okay, so it's kind of a little bit opposite, but has the same principle behind it. I have to know whether or not it's going to be hard or easy to take an electron from a particular element. So ionization energy increases as you go across the period, but so did electronegativity. It is harder to take away Fluorine's electron because she has a tighter grip on her electrons because she has the most number of protons in her nucleus of anybody in her same period. So she is holding on to the electrons that are in her outermost energy level with all of her might because she is only one away from getting to have noble gas configuration. So she's not going to let go of any of these 7 electrons that she currently has. She's holding on to them tightly, so it's going to take a lot of energy to get her electrons away. So it's an increase in the number of protons, which increases the effective nuclear charge that makes it hard to get Fluorine's electrons away from her. Okay, so it decreases as you go down a group. So let's talk about poor Mr. Francium. So what does Mr. Francium look like? Well, he's got a lot of electrons and he's got a lot of protons, but let's talk about those 87 protons that he has and his 87 electrons. His electrons are distributed in energy levels 1, 2, 3, 4, 5, 6, 7 energy levels. And he's got an electron way out here. He's got, remember, 1 valence electron in its outermost energy level. And the question is, how easy is it to take away this electron from Francium? Keep in mind, Francium doesn't actually want that electron. That electron is keeping him from having a full outermost energy level. If he could get rid of that electron, he'd be more stable. So he wants to get rid of that electron. So the question is, how much energy does it take to take something away from somebody if they don't even want the item in the first place? It won't take that much energy at all. So it's going to decrease as I go down a group, because as I go down a group, my size is increasing because there are more energy levels and there are also more shielding electrons that's preventing my positive nucleus from being able to pull in this outermost electron. So the shield electrons that are blocking my nucleus from pulling in that electron are keeping me from being able to keep that secure. And so it's not very much energy at all for somebody to come by and take away that 87th electron from Francium. So on your ionization energy, it decreases as you go down and it increases as you go across. Remember, there's 2 elements that we're going to talk about here. This has the lowest ionization energy. This one has the lowest. Now remember, Francium is our guy for lots of things. He's our largest element on the periodic table. He's our smallest electronegativity. And he's got our lowest ionization energy. The ionization energy of francium is 9.39. That's the amount of energy that it takes to get the outermost electron, the first ionization energy. Let me be clear, there's lots of ionization energies, and in this class, we're only actually going to be talking about first ionization energy. All right, so we're not talking about, there is for electrons, every electron has its own ionization energy. So there's the amount of energy needed to take away that 87th electron. There's a different amount of energy needed to take away the 86th one and the 85th one. So, but we're only going to be talking about first ionization energy, which means the amount of energy needed to take away the outermost energy level. And helium has the highest ionization energy with 24.5874. He doesn't want his electron to be taken away in any way, shape, or form, because remember, he has achieved noble gas configuration. He's got his 2 electrons in his 1 energy level. It's full, and he in no way, shape, or form wants to give away. Now that's a little bit different than electronegativity, because remember, electronegativities didn't exist for this side of the period, for the for the noble gases. So the noble gases did not have a electronegativity, but they do have an ionization energy, which is the amount of energy needed to remove an electron. So if we know francium's is the lowest and helium is the highest, we can answer any question about a trend. So picture the periodic table and what you know about the 2 elements, the one with the lowest ionization energy and the one with the highest ionization energy, and answer the following questions. Which has the higher ionization energy, lithium or carbon? It's asking for larger. That means that it's whoever is closest to helium, because that is the side of the periodic table that has the higher amount of electronegativity, because it is electronegativity too, but not for helium, of ionization energy. So both the trend for ionization energy and electronegativity are very similar. The only difference is that the noble gases do not have electronegativities. They do have ionization energies. So lithium or carbon, who's closer to helium? The answer is carbon. Sodium or potassium? Sodium or potassium? Who's closer to helium? Sodium. Boron or beryllium? Boron or beryllium? Who's closer to helium? Boron. Bromine or fluorine? Fluorine or bromine? Who's closer to helium? Fluorine. Nitrogen or phosphorus? Nitrogen or phosphorus? Who's closer to helium? Nitrogen. Boron or nitrogen? Boron or nitrogen? Who's closer to helium? Nitrogen. So if you know which elements are your key elements in learning the trends, then you can figure out your trends easily. So there are 4 trends to know. The first day we did atomic radius and ionic radius, and we said that it got smaller as we went to the right and larger as we went down, and we know that francium is the largest of your atoms, and so whoever is closest to francium is going to be the largest in size. For ionic radius, we actually have 2 different trends. We have a cation trend and we have an anion trend. So remember that the cations give away their outermost energy level and therefore get smaller than their atom size, but they still get smaller to the right. And anions are larger than their atom size because they gain electrons into their outermost energy level. They don't lose electron energy levels. See, in a cation, you lose your energy level completely. So when you create the ion, you lose this outermost energy level. And so a cation is going to be smaller than its atom, and an anion is going to be larger than its atom. But they still decrease to the right, and they still increase as you go down. The next two were today's lesson, and today's lesson was about ionization energy and electronegativity. Ionization energy is the amount of energy needed to take away an electron. And electronegativity is your ability to attract an electron while in a compound. So remember, we had our elements for this as well. So francium was our lowest for our electronegativity, and helium was our highest. And for I think I might have said electronegativity there, ionization energy. And electronegativity, francium was our lowest again, so he's the lowest for both of those, but fluorine is our highest for electronegativity. Okay, so this is the highest. Okay, so francium has the lowest for both of these. It has the largest for this. So if you learn what you need to know about the element francium, he will help you in understanding and getting your trends correct overall. So here are the trends in illustration form. For size, increase as you go down, decrease as you go across. So that is where francium is on the periodic table as your smallest. For ionization energy, it decreases as you go down and it increases as you go across. And so remember, we have two elements for this. We have helium for our ionization energy as the largest, and we have fluorine as our largest for electronegativity. And for smallest for everything, we have good old francium. He is the lowest ionization energy, and he is the lowest electronegativity. So it is the lowest is francium for both electronegativity and ionization energy. So if you know any one of the two trends, you know them both because it's all about opposites. Look, these words are placed here opposite from each day. So decrease to the right, this says increase to the right. Increase going down, this says decrease going down. So if you know one of the two trends, you know both of the trends because you could just remember it's opposite. The reason that they happen is the same. Everybody's reasons are the same for going across. The reason is you keep gaining protons, so you have a higher effective nuclear charge. For any reason going down, the answer is you keep getting bigger because you have more energy levels and more shielding electrons. So our reasons for why that happens as we go down are the same, no matter whether you're talking about atomic or ionic radius or electronegativity and ionization energy.